Hello students, in this lesson, we'll be going through this worksheet 4.2 and 4.4, to understand about distillation, and the next one we'll talk about it is paper chromatography. So these two are different separation methods as compared to the previous three that we have learned so far. What are the previous three? The previous three would be evaporation, filtration, and magnetic attraction. So without further ado, let's start off with this particular one. For distillation, please take note that distillation, the objective is to really get a certain thing, a certain thing from the mixture. So the objective of distillation is to obtain a liquid. So the objective of distillation is to obtain a liquid. Please take note. On the other hand, you have learned previously about evaporation. So the objective of evaporation is to obtain a solid. So when you obtain the solid, I forgot the word obtain. This solid has to be stable with heat. So there is a second condition. This solid was actually soluble in the solvent. Most of the time we are talking about liquids like water. But also at the same time is stable with heat. So is a little bit different from the other things that you have learned so far. So evaporation is not really the main factor here. So first up, when we talk about distillation, you have to know this particular diagram. Please memorize this diagram. Is very important. So this diagram is very important. I say again, you must know this diagram very well, especially the intake and output valves of the condenser. Where is it supposed to be? Next up, you need to know this word distillate very well as well. Basically distillate is the liquid that you obtain from distillation. Next up, let's look at the first question. The first question, name the two main physical processes that is required in the distillation. If you have referred to my this video, or to the textbook, you'll be able to know that the two physical processes they require is actually vaporization and condensation. So what is vaporization and what is condensation? Vaporization is the changing, converting liquid to gas. This happens inside the flask with the boiling chips. On the other hand, condensation is converting gas to liquid. This occurs in the condenser. So these are things that you need to take note. So I will use this I'll use the diagram here. When you talk about vaporization, it's going to be a bit messy here, so let me use different color. When you talk about vaporization, vaporization happens here inside the boiling this round bottom flask, where the boiling actually occurs. On the other hand, condensation happens in the condenser. So these are things that you should be taking notes. Next up, what are the precautions for the thermometer and the condenser? So many of you have written down that the thermometer will break and so on and so forth. Those are not precautions. Okay, so you have to know that when we talk about precaution, it's actually things we need to safety features or safety, not safety, sorry, things we need to take note of when we are using it. Okay, so I put it down here. Things that we need to take note of while using. Okay, so it's not exactly about the dangers, okay, but rather it's actually when you use it, what are things that you need to take note of. Okay, so for the thermometer, okay, the precaution should be the bulb of the thermometer is at the mouth of the condenser. Okay, so what do we mean by this? Okay, if you look back at the diagram above, okay, you notice that uh, the bulb of the thermometer is actually at the mouth of the condenser. Okay, so this is the part that we are referring to. Yeah, so when you look at all these, please be very very careful. Okay, so why do we want it to be over there? Okay, what's the explanation? Basically, this will ensure the bulb will measure the temperature of the vapor that is going into the condenser. Okay, so the explanation would be to measure the temperature of the vapor entering the condenser. Okay, so when we do that, when we do this, then we are able to tell the which liquid is actually going to be coming out. Okay, because the boiling points of the liquids are different, and we can actually identify the liquid, okay, based on the temperature alone. Okay, so for the condenser, the precaution would be, okay, it's slightly different. Let me use a different color. Okay, for the condenser, you have to ensure that the water in is at bottom. Okay, I put it in very simple terms for you. Okay, and water outlet is at top. Okay, so sorry, now let's go back to the diagram again. Okay, notice that I'm actually talking about this portion. Water in is actually at the bottom, okay, and water out is actually at the top. Okay, why do we want to do this? Okay, so the explanation is actually very simple. Okay, basically we know that hot water, okay, or warm water is actually less dense than the cooler water. So by putting it in this way, the cold water will enter in, okay, from the bottom, okay, while the warmer water will be able to exit easily from the water out, which is at the top. Okay, this will ensure effective cooling of the condenser. Okay, so the overall objective of putting the water in at the bottom and water out at the top is basically to ensure, okay, effective cooling of the condenser. Okay, so it's to ensure the effective cooling of the condenser. Okay, so let's move on. Okay, what is the purpose of a condenser in the distillation? So you have seen in the previous part, okay, the purpose of the condenser is basically to change a vapor into a liquid. So answer is D. Okay, so state one application of distillation. Okay, application, again, the word application here means a use. Okay, so state a use of distillation. So there are quite a number of uses of distillation. One of the most common uses of distillation would be to uh, separate separate the what is that called? Separate water from seawater. Okay, water from seawater. Okay, there are many other uses. Okay, so other examples would be to separate the petrol, okay, the kerosene from the crude oil. Okay, so because crude oil is actually a mixture of many different fossil fuels. One of the fossil fuels that we use very commonly will be the petroleum, okay, which is one of the many that can be extracted from the crude oil. Okay, others will include kerosene, okay, and other different types of fuels. Okay, okay, next up. Okay, for question 4, many of you do not have any idea what is happening, so your answers tend to be quite weird. Okay, so let's stick to something simple. Okay, let's just stick to separate water from seawater. Anyway, this is also one of the things that Singapore do to continue to make water available for us. Okay, so this happens in our desalination plants in Singapore. Okay, question 5. Okay, question 5 is actually a repeat in a different way. Okay, repeats of the understanding that is required. Okay, so notice in this portion, the water inlet and the water outlet is already wrong. So this is actually one of the errors. Okay, where is the second error? The second error is actually the position of the bulb of the thermometer. So describe the two errors. Okay, first error would be the bulb of the thermometer. Thermometer, okay, is not, okay, at the mouth of the condenser. Okay, the second problem would be the water in and water out of the condenser is swapped. Okay, or switched. Okay, let's use the word switched. Okay, so like what I've mentioned before, when the water in, okay, is at the top and water out is at the bottom, okay, there will not be effective cooling of the vapor that is going to go through the condenser. Okay, at the same time, when the bulb of the thermometer is not at the mouth of the condenser, we will not be able to really measure the correct vapor, okay, the temperature of the vapor that is coming out, okay, and proceeding into the condenser. Okay, so next part, okay, question 5b. Okay, name the physical change taking place at A and at B. Okay, down here when they talk about physical change, okay, they are actually talking about what is happening. Okay, so you have to actually mention in part A, even though it's vaporization, vaporization is a process, okay, but it's not a physical change. Okay, so you need to mention that A is actually liquid, okay, to gas. Okay, while B is actually gas or vapor to liquid. Okay, avoid the use of arrows. Okay, please do not say gas, arrow, liquid. Okay, if you do that, this is wrong. Yeah. Okay, part C, draw arrows on the above diagram to show how the vapor travel in the setup. Okay, so let's refer back to the diagram. Many of you, when you did this portion, I don't think you actually notice or this part of the question. Either that or you choose to skip. Okay, many of you actually chose to skip, so this is a problem. Remember, I told you during lesson, okay, that you should be attempting all questions. Okay, all questions you should be attempting it rather than leaving it out. Okay, then only then you will learn. Okay, so anyway, vapors will start from the liquid itself. Okay, you go up the round bottom flask over there. Okay, and from there you travel through the condenser. Okay, and from the condenser it will move through to the end here. Just before exiting the condenser, you become a liquid already. Okay, so the basically the vapor will only stop at this condenser itself. Okay, next up, state the generic term used to describe C. Okay, so the generic term here is the distillate. Okay, it's the distillate. Okay, actually this answer is already found in the previous part. Okay, so where's the previous part? If you look back all the way at page 1, okay, distillate, D-I-S-T-I-L-L-A-T-E. Oh, I missed out a L there. Okay, let me add in the L. Okay, D-I-L-L. Okay, double L's. Okay, so which liquid will be obtained first? Okay, and explain why. Okay, so like I mentioned before, okay, when we talk about this distillation, we are actually trying to obtain some form of liquid. Okay, so if you look at this question, ethanol and water, okay, ethanol has 78 degrees Celsius and water has a boiling point of 100 degrees Celsius. So when we heat up the mixture itself, the definitely will reach 78 degrees Celsius before reaching 100 degrees Celsius. So what is going to happen? Okay, basically at 78 degrees Celsius, ethanol is going to vaporize. Okay, so after ethanol vaporized, okay, it will travel up, okay, to the top of the round bottom flask, and then after travel into the condenser, which will then condense it into ethanol again, and you drip out as a condensate for ethanol. Okay, after which the temperature will continue to rise. Okay, so after this ethanol has fully been removed from the mixture, okay, the next temperature is going to reach is 100 degrees Celsius. Okay, at 100 degrees Celsius, okay, this water will be vaporizing. Okay, and you also travel through this same path, okay, and condense in the condenser before coming out to the as a distillate itself as well. Okay, so having said all that, my answer is already as what I've mentioned. Okay, ethanol, okay, will be obtained first. Okay, why will ethanol be obtained first? Okay, this is because the boiling point of ethanol is lower than water. Okay, so please take note of which one will actually come out first. Okay, which one will be the distillate first. Okay, next, okay, question 6. Okay, question 6, which part has the similar function as the water flowing in the condenser? Okay, so basically which part actually simulate the condenser? So you need to know that the condenser, the objective of the condenser is to cool vapor and change it to liquid. Okay, so the key idea is actually to cool. Okay, so once you understand that, okay, if you look through this setup in question 6, you notice that the only part or the only portion that actually cools down anything is the ice cube. Okay, so the ice cube in the beaker actually will so-called simulate the this condenser. So answer is actually C. Okay, so please do your corrections, okay, and learn from all these mistakes. Yep. So this is for question. Sorry, this is for worksheet 4.2. Okay, let's move on to worksheet 4.4. Okay, in worksheet 4.4, we are talking about paper chromatography. Okay, but for paper chromatography is slightly different from the others. It really doesn't really it doesn't really able, okay, it's not able to give you a actual thing to use at the end. Okay, so but it can actually help us separate certain things to help us understand what is actually involved in those mixture. So example will be down here. There's already given the ink. Okay, in this question they use ink as an example. Ink is separated by paper chromatography, so we will be able to show or see what is making up the ink itself. Okay, so the precautions are already stated in this portion itself, so please take note of the precautions. Okay, so what are the main precautions? Basically the line, okay, there is drawn, okay, over here, the line drawn is actually in pencil. Okay, why is it in pencil? Because we do not want it to contaminate the results of the item that we are testing for. So in this case, the ink spot is the item that we are testing for. Next up, okay, the water or the solvent have to be below the line itself. Okay, this is also to make sure that the this sample, okay, the ink spot or whatever that we are testing for does not dissolve in the solvent. Okay, so we must choose something that the thing that we are testing for can be dissolved in. Okay, sample size must be small. The sample dots must be small in size. Okay, why? Because we do not want it to basically overlap the results of others. Okay, the bigger it is, the more it will overlap and the less accurate you become. Okay, next, okay, you have to make sure that the time taken, okay, for the whole experiment to take place is sufficient for the this paper chromatography to take place. Okay, so what do I mean by that? What do we mean by that? Basically, it must have enough time for the ink spot to start from the start line here and go all the way. Okay, the water, the solvent must reach all the way to the end. Okay, you cannot stop halfway. Okay, if you stop halfway, the results will not be accurate. Okay, so moving on. Okay, the container is actually covered with a lid. Okay, why should it be covered with a lid? Basically, is to prevent basically is to prevent the water from or the solvent from evaporating. Okay, because once it evaporate, it will actually affect the results. Okay, it will not be so accurate. Okay, so for question 1, okay, listen very carefully. Okay, whenever we talk about paper chromatography, okay, why the spots are able to separate in the first place, okay, or why do we even see all this in the first place is because the spots or the ink, in this case is dye, okay, the dyes are soluble in the solvent. Okay, so but the thing is each dye has a different solubility. Okay, the more soluble one would be the one that travel the furthest, okay, and the least soluble one would travel the least. Okay, so the yellow spot is actually the most soluble, okay, in solvent. Okay, please take note how do we actually read the whole thing. Okay, and while the brown spot is actually the least soluble, okay, in solvent. Okay, notice I did not mention water. Okay, basically it the solvent need not necessarily be water. Okay, so please take note. Okay, it must be something that the dye or whatever that we're testing for, it can be dissolved in it. Okay, so explain why the spots are able to separate. Basically because the dyes have different solubility. Solubility in the solvent. Okay, so when there's different solubility in the solvent, okay, it will the traveling time, not it, the traveling, okay, it will move, the dyes will move, the dyes will move at different rates. Okay, so when we have this, okay, that's why the dyes will be able to separate. The most soluble one will travel the furthest, okay, while the least soluble one will travel the least. Okay, so which color spot is the most soluble? I already given there. Answer is actually yellow spots. Okay, how many dye components are there? Okay, you count the number here. Okay, so there is 1, 2, 3, 4. There are actually 4 spots here. So the number of components is actually 4. Okay, so please read the diagram carefully. Okay, don't be complacent. Okay, many of you are not attempting the questions at all, just doing it blindly. Okay, next up, describe what will happen if the die has been placed at X on the filter paper. So if my die is placed at this position, the X, okay, what will happen basically? Yeah, so if you look back at the top here, okay, the answer is already present. Okay, so where is the answer? Okay, the answer is actually down here, here. Okay, the start line is placed above the solvent. Okay, so this is to ensure the samples move up the paper instead of dissolving into the solvent. Okay, so this last part that they mentioned here is actually the answer to the question that we are looking at. Okay, so going back to the question below, describe what will happen if the die has been placed at X on the filter paper. Okay, so basically the die will dissolve in the solvent. Okay, instead of traveling up the paper. Okay, so these are things that needs a little bit of thinking, okay, but you can actually answer it. Okay, you just need to try it. Okay, so moving on to question 2. Okay, which of the following is a correct conclusion about dyes in the chromatogram? So you notice that in this question, V, W, X, and Y, okay, they have moved to different positions, and V did not move at all. So when V did not move at all, it actually indicates that this V, okay, V is, okay, this V is insoluble in the solvent. Okay, it basically cannot dissolve in the solvent. That's why it doesn't move from the original position. Okay, on the other hand, W, X, and Y are able to show us something. Okay, next thing you notice that W and Y are singular, okay, while X has more than one. Okay, so when a chromatogram shows you more than one things inside, more than one dye inside, actually this tells us that X is a mixture. Okay, X is a mixture. It's made out of two things. It's unlike W and Y. W and Y are actually made out of one thing. Okay, so if you look at the answers that is given, okay, based on what I mentioned just now, the answer that we have is actually, or we need, is actually A. Okay, W and Y are pure substances because there is only one dye that has moved out from that position, the original position at the start. Okay, so that's actually our answer already. Okay, so for question 3, Okay, the chromatogram, okay, shows the dyes present in 4 different soft drinks P, Q, R, and S, and in 2 dyes X and Y. Okay, so there are a lot of things that are given, but take note that X and Y are both harmful. Okay, so they are basically telling you that the dyes here are harmful. Okay, so if any of the soft drinks actually contain these 2 dyes, that means they are also harmful. Okay, so whenever you face with such a question, the first thing you do is actually go and take a ruler and draw lines, okay, across to see whether any of them matches. Okay, so let me draw all the lines first. Okay, I'm using my free hand here. Okay, but you should be using your ruler. Okay, so why do I want to draw the lines like this? Okay, so if you look very carefully down here at X, this position, it corresponds to one of the spots in P. Okay, for the Y position, it corresponds to one of the spots in Q. Okay, so this tells us that this P, okay, soft drink P actually contain dye X, and soft drink Q actually contain dye Y. So you already have your answer because they are asking for which of them contains the harmful dye, which is P and Q. Okay, so basically the chromatogram, we use it this way to help us to identify what is actually present in the other. Okay, so if you look at the maybe let's use a different color. Okay, extended example. Okay, if you look at maybe R and S, okay, you notice that R and S has these 2 spots that are similar. Okay, so you can actually suggest, based on this observation, you can actually suggest that probably this soft drink S has the same 2 dyes as soft drink R. Okay, so you need to draw these lines to help yourself identify which is present and which is not present in the other. Okay, so a lot of the paper chromatography is actually using the chromatogram to compare, okay, against something that we know, and then propose something. Yeah, so let's move on to the next question. Okay, this is actually based on the previous idea. Okay, we need to compare. Okay, but anyway, which dyes are or is or are pure? Okay, so answer is actually let me use blue as writing. Okay, answer is A, is dye A is pure dye. Okay, because dye A only has 1. Okay, so look carefully here, dye A only has 1. Okay, dye F only has 1 as well. Okay, so answer for this one is A and F. Okay, which dye is insoluble? Insoluble means it doesn't move. Okay, so in this question, actually dye B is insoluble. Okay, we can't conclude about dye G, even though dye G also has something that is left there. Okay, but you also notice that dye G has these 2 that is on top. Okay, so there are parts of dye G that is actually soluble, and there are parts that are not soluble. Okay, so because of that, we are not able to conclude about dye G. Yeah. Okay, next question. Which dye can be mixed to give dye D? Okay, so same thing as what I mentioned before. Take your ruler, okay, draw lines, okay, to help you to identify which is present in dye D, okay, and which one does it correspond to in dye the other dyes. Okay, so if you look at the dye D is this, and this. Okay, these 3 dyes. Okay, which one does it correspond to in the other dyes? So you notice that dye D, to the right of the first spot here, dye E, actually one part of dye E is contained inside dye D, as well as the top one here. Okay, so this dye E probably is inside dye D. Okay, on the left side, okay, you notice that C, this spot C actually corresponds to dye D, the center spot there. So it actually tells us that dye D is made up of C and dye C and dye E. Okay, so imagine die C and die E superimpose on each other, you mix together, you actually get the answer there. Okay, so C and E is the answer. Okay, draw on the diagram, okay, part D, draw on the diagram to show the result of the separation of H if H contains C and F. So now they are telling you that H contains C and F. Okay, so going back to the question itself, okay, when you contain C and F means I must see the same, I must see the dies of C and the dies of F on H itself. Okay, so what is C? C, if I extend this a bit further, okay, it'll be over here, so I should see a die that is over here. Use your ruler, please. Okay, and F, you look carefully, it should be over at these spots, and it should be a bigger round circle. Okay, probably something that looks like this. Okay, so it's actually very easy to use. Okay, and I would like you all to always remember how do we actually use a chromatogram. Okay, so I should see an answer on the top part here, the diagram here, as something like this for part D. Okay, last question. Okay, part E, state one application of paper chromatography. Okay, so this is the part where some of you gets confused. Chromatography is a method of separating things. Okay, separating certain things. Okay, you can even use it for urine samples, DNA, and all that. Okay, but for paper chromatography, okay, paper chromatography is very specific. Okay, you cannot use it to separate urine samples. You are not able to tell. Okay, you won't be able to tell. Okay, you can use chromatography for other things. Okay, but not paper chromatography. Okay, you cannot separate DNA samples from paper chromatography, but you can separate DNA samples using chromatography. Okay, so there are other types of chromatography out there that will do the job, but not paper chromatography in this case. Okay, so looking back at the question, okay, state one application of the paper chromatography. Okay, basically we are looking at identifying or separating. Okay, identifying maybe approved food dyes. In food. Okay, so this is something very simple. Let's keep it to this one. Identifying approved food dyes in food. Okay, so any question here? Please ask me separately. Okay, otherwise these are the answers for worksheet 4.2 and 4.4. Okay, so I'll see you all again on the next lesson.